Hi guys, welcome to my channel. My name is Chidi. In this tutorial, you'll learn how to build two powerful types of machine learning projects. One that makes prediction using images and another that makes predictions using tables or CSV file. So let's get started. Now, this is an example of a spreadsheet which we're going to use as our data set for our projects. And this is an example of our data sets of images. As you can see, this is the folder pet images. We have a subfolder for dog and cat images. If I open this, you see there are so many photos or pictures of dogs in this folder. You can see this is a photo of dog. There's so many photos and pictures of dog in this folder. Also in this other subfolder, we have that for cats. So there are two types of data set which we'll be using in our project. One is this type. We have photos and images. We're predicting based on these data sets. And the other is when we have spreadsheets like this. The spreadsheet, it has rows and columns. You can see each of the headers, this frequency signal. For example, we can be given an input of frequencies, signal strength, modulation, bandwidth, and might be asked to predict based on this or input if the weather is cloudy or rainy. So that's when we use kind of data set. The first stage for prediction of images or prediction using spreadsheets or CSV file is data collection. So for images, the data sets are usually collected from sources like Kaggle, and they are labeled into folders like cats or dogs or sheep or any other thing, depending on what we are actually working on. And for tables, we also use Kaggle or other open sources online, but the data comes in form of rows and columns. So after we have collected our data, the next thing we do is process those data, which is called data processing. So for images projects, this means resizing, normalizing pixel values, and ensuring all our images are in the same format. While for tabular data, processing could involve scaling numbers, like bringing everything into a range of 0 and 1, and converting text into numerical formats. The next thing for images is data augmentation, while the next thing for tables or tabular data is feature selection. So now, here's where things differ. So for images, we use data augmentation like rotating, flipping, or zooming the images to create more samples and reducing overfitting. While for tables or tabular data, we apply feature engineering, which involves creating new columns, transforming the data, and also selecting the most relevant features. Now, the next stage is data splitting or splitting of our data set or our data. So in both cases, for images and for tables, we have to split our data sets. So after preprocessing, data augmentation, we split our data for images. And in image projects, we physically move files into training and testing folders. This is what is called splitting, to move the files into training and testing folders. Then, for tables, splitting involves using Python code to split rows, the rows of the tables into memory, into S and Y variables for training and testing. Now it's time for us to build the model. After splitting our data, the next thing is to build the model. In both cases, after splitting the data, the next thing we do is to build the model. So for images, we usually use CNN, which is convolutional neural network. It's a very powerful tool for understanding pixels because images are seen as pixels. While for tables, we use models like random forest or we use XGBoost. They are very good. They are great tools for learning from structured data. All right, at this stage, we have built our model, which is the brain. We've built our model in both cases. Now we have to train our model. Building a model is like the brain, like in a human, while the model training is like telling it how to think. The brain can be in a human's head, but you need to tell it how to think or feed it a certain information to make it think in a certain pattern. So during training, the model learns patterns from the training data, which has been given as scripts. The computer adjusts itself based on how it's well performed in both cases, whether it's a CNN or conventional neural network, which is learning edges of maybe a dog or trying to learn how the certain numbers are formed, or a tree model finding patterns in numbers. This step is where the magic happens, and it is very, very important in our project. At this stage, after training the model, the next thing to do is to evaluate our model, which is called model evaluation. And model evaluation is similar in both cases. What is model evaluation? It's like testing a model on unseen data. Now we've trained it, we have to test it on unseen data, what it has not seen before. It needs to learn from what it has not seen before. So once the data is trained, we test it on unseen data. So for both types, we use metrics like accuracy, precision, recall, or mean squared error, depending on the task. That's what we use for our model evaluation. And finally, model prediction. So for images, you might upload a photo and the model will tell you this is a dog or this is a cat. Why for us to predict for tables, you might enter a few numbers and the model might predict the likelihood of something happening, like a student passing an exam or failing, or the total number of students is 15 or something like that. So to wrap up, image-based projects deals with pixels, like I said initially, and it relies heavily on CNN, which is convolutional neural network and visual data, while table-based project works with structured data and needs smart feature selection. In conclusion, using images as your data set or spreadsheet, which are tables, or CSV file as a data set for your project, they both follow a similar pipeline. It starts from data collection, data processing, data augmentation, your splitting of your data, model building, model training, model evaluation, and lastly, model prediction. So in both pipelines, they are similar. Just few lines of code to tweak and your project is perfect and your prediction is accurate. So if this video has really helped you, I would like you to like and subscribe to our channel.